I'm Troy McGinnis, and I want to introduce PromptOpsKit, a new free library that I've used to manage prompts inside my applications. Now, what I have here is a brand new basic Next.js application. It's just if I go to localhost, you'll sort of see I just saved some time by doing a creation of a brand new Next.js application. We're going to enhance that now to add LLM capabilities using PromptOpsKit. Now, PromptOpsKit is open source. What it aims to do is bring together all of your LLM prompt management, because in today's applications that are very AI heavy, you have the prompts, the system instructions, you have the tool sets, and you have the validation of how you inject context data at runtime, all spread out over the application. And what I've tried to do with PromptOpsKit is bring that all together in one place. So let's go look at a demo there. Now, inside your terminal, there's a couple of things you need to do to start off with. The first one is you need to install the package. So I'm going to do npm I PromptOpsKit. npm I PromptOps. I'll get this right. PromptOpsKit. It's a very light package with only 2 reference and dependencies, very small. Now, to use it, what I suggest is running our init package. So npx PromptOpsKit init. Now, what it does is it goes and creates you a prompts folder, and this is where you're going to put your prompts. And let me sort of explain how it works. First of all, a prompt has a top level section of metadata that describes the basics, the models to use, the reasoning level, and includes. Now, one of the things that I needed to do quite often was inject variables at runtime. So in this case, the name of the person and where they are in the application. This is a hello world prompt. I know it's blasé. The other thing you can do there is you can specify different environment overrides. So whereas it would generally use what is in the top level defaults, which would be GPT 5.4, if they're in the development environment, which you specify when you resolve the prompt at runtime, it will use GPT 5.4 mini with low reasoning effort. Why? Because there's no use using the highest power model. During development, you're just going to burn extra tokens costs for no real reason. Now, under that, 2 areas in Markdown: system instructions and the prompt template. And what the system instructions do, everything cascades. So again, if you have these system instructions in the top level default of the folder under prompts, you'll get your helpful AI assistant, follow company guidelines at all times, combined with you are a friendly assistant, be helpful, concise, current app context. So the system instructions cascade down, so you can put different things up the top that you may need. And you can also create sort of snippets of those, like tone, to make sure that wherever we do 2 curly brackets, tone, curly brackets, this will be injected in. But we'll look at that later. Now, what happens is during development time, you just edit these markdown files and everything will operate. At runtime, then, what we sort of want to do, though, is compile them. So if I do npx PromptOpsKit compile, what you'll sort of see is another folder up here will be generated. In this case, what it will be, it's in a compiled state, which is faster to use at runtime, and it means you don't have to ship these markdown files. You just ship either the JSON or ESM modules, and that helps at runtime efficiency and so forth. So let's make one of our own. I've got one I prepared earlier here, of course, which is for summarizing pull requests. So let's go and create that one. So to create a new prompt, what you need to do is just come into here, create a new file, summarize pull request.markdown, and then we paste in the file that we want. Now again, I've given this a unique ID of summarize pull request. The environment, again, I've overridden GPT 5.4 mini when we're in dev. I'll show you that in a second. And then in this case here, we have what it takes in is the pull request. Where does it take it? It takes it in the prompt template. Summarize the following pull request. Curly bracket, pull request body, curly bracket. Now we inject that at runtime. And when we're injecting it, we get to do some validation. We can set its maximum size. We can sort of give it a regex of what it's allowed to be, no special characters. And then we can give it a deny regex that if it contains, your patterns will be better than mine on these, but if it contains the word secret, API, key, or password, it's going to not execute. It's going to return a message, a secret was detected. You can either do this one or two ways. If you have return message, it returns a message. If you leave it out, it creates an exception, which you can wrap your prompt generation in a try catch, and then sort of say, sorry, there was a secret detected and I don't want to execute that. The other thing you can have is another section in your prompt notes. These are just for your developers to understand the logic or to put checks in. This is your Scratchpad area. It doesn't get included at runtime. It's just there for you at the develop time. And again, what we want to do is we want to compile those and get them used. Now, at the moment, they're not being used anywhere. I've got a page I created earlier, which sort of builds an example app. Of course, I vibe coded it, so we don't need to look at that one so much. But what its intention is going to be is it's going to pass in a fake pull request body, and it's going to hopefully summarize it. So let's go and implement that part of the code now. Now, I'm going to run you through how this works. I'm going to overwrite all the Next.js default template with our own. Now it's complaining because I don't have OpenAI installed. I'm just using OpenAI. You can use OpenAI, you can use Anthropic, you can use Google, you can use OpenRouter, and I'm sure we'll provide others. But I do need to do an npm install OpenAI to get that library installed. All right, now the errors go away. So how do we use these prompts at runtime in our code? Well, essentially, we can call, in this case, the OpenAI adapter or the Anthropic adapter, the Google adapter, and what we pass it is the prompt that we want to do, summarize pull request. Now, the system's pretty smart. It'll use the markdown file that we have if it's newer, because we're editing and we're developing on it. But if that's not there, it's going to go up and it's going to use the compiled JSON version or the ESM version at runtime. And why do we use ESM? Sometimes to deploy them to AWS Lambda or some of those places, it's easier to deploy them as part of the package and just import them into your code. So we're very flexible there. Now, this takes in a couple of extra runtime render options. The environment, and in this case here, what I'm going to pass in is whether we're in dev or prod. Now, remember earlier in the prompt, we sort of use a different model, whether it's dev or prod. This is how I'm going to control that. And the pull request body that we had, again, if I go back and show you the prompt, pull request body was the input of the context that we had. So what we're going to do here is we're going to assign it whatever we pass into this function that I've created. It's a server-side function, because you make AI LLM calls on the server side for security because you don't want to expose your API key. We pass in pull request body. Now, there's one special case. What this does when it returns is it returns the body of the LLM OpenAI call that you need to make, or the Anthropic or the Google or the OpenRouter. Whatever specific model you're using, it will create the right body to send to that vendor. And what we've got down here is a special case. Remember that validation rule that sort of says if you have the word secret in there, where it has the word secret in there, we will get a return message rather than a body for the LLM vendor, an OpenAI body, completion body, and we just return that message. I'll show you that in a second. But once we've made the call to render the prompt, render the body that we need from the prompt, we can just call it in whatever, in the OpenAI SDK or straight using a fetch to the OpenAI API. And that's all we have to do. What we're doing, though, is at runtime, everything about the call and the body of that call is contained in one spot. All right, so I think I still have the application running there. Let's go and have a look at it. So this is the code we just put in. This is that example fake pull request body. And when I hit run prompt, what it's going to do is it's going to run that function we just saw. It's going to render it, and we will get back our response from OpenAI doing that prompt that we sort of said. Now notice it used GPT 5.4 in that call. But if I change and pass the dev environment and I run that again, what we're going to get is GPT 5.4 mini. So you can control that runtime, what environment or what customer tier is running, and it does the job. So the whole pipeline is this. You start off with a prompt markdown with all of the defaults and the inheritance of all the different models and temperature and whether there's caching and so forth, and tool sets or MCP servers. And then what we do is we have all the validation around the injected variables. So it goes from the prompt markdown, we compile that for speed and performance. Whether it's JSON or ESM, it means we're not having to parse markdown at runtime, we're parsing a JSON structure already. Now when we render that into a prompt, that's when the decision's made about what environment are we in. And because the last call was in the dev environment, the model got changed. And all of our inputs here and all of our prompt structure got resolved into what will work on the OpenAI router, including injecting in the pull request text that we had. Then we call OpenAI to do its magic. It comes back with the result. All right. So that's the process. Now, remember we had that validation on that input on the pull request, and if we had the word secret anywhere in there. So if I put the word secret in there and try and run that now, what's going to happen is it's not going to execute it. It's going to say a secret was detected. And you're able to do validations in some pre-built ones. They can't be empty. It contains secrets, or you can build your own allow regexes or deny regexes to trap certain things you don't want to allow to come through. So the process and the workflow is really you install the PromptOpKit, you initialize it to get your prompts folder, you create your prompt definitions, however you want them to be, and then when you've got them the way you like them, you develop against them. You render them at runtime by calling them by name and injecting in any of the input variables that you needed to inject. And then when you're ready to deploy, you can compile the text markdown prompts into either JSON or ESM strings and types, and then everything is efficient from there. The only other thing I want to sort of mention is you don't have to go this alone. If we have a skill, if you do npx PromptOpsKit skill, what happens is it will instrument all of the cursor, all of the Claude and the codex sort of prompts, and it won't overwrite yours. It'll put its own section in, and it actually references the skill markdown that we supply for you, so that you don't have to go it alone. So that's about all there is to sort of demo at the moment. If you go to PromptOpsKit.com, you'll sort of see everything we just described, what it's trying to be, control layer, composable, and so forth, and some worked examples. I hope you like it. Again, it's open source, so I'm hoping to get help on building this out and adding more providers over time. Thank you, and I hope you have a great day.